When I was a kid, my bedroom was an absolute hazard zone of rocks I had hoarded.
Oh, I can imagine.
Yeah, I was so convinced I was finding these rare meteorites everywhere I looked.
Let me guess, they were mostly just...
Driveway gravel.
Right, yeah.
Exactly. Driveway gravel, or worse, just chunks of melted green bottle glass from a neighborhood bonfire.
Classic.
Right. But I really thought I was holding a piece of the cosmos when it was usually just discarded debris.
It is a common mistake, honestly.
It is, but that childhood obsession perfectly sets up our mission today as we look at our stack of sources all about tektites.
And since you likely already know these are terrestrial impact ejecta, our goal today is to really look past the basics.
Right. We are going to explore the thermodynamics of how these hypervelocity impacts flash melt Earth rock into aerodynamic glass.
And what that process tells you about the dynamics of our solar system.
Okay, let's unpack this because the thermodynamics here are just intense.
They really are. We are looking at an event where a meteorite strikes the crust at tens of thousands of miles per hour.
Which is just staggering.
Right, and that sheer kinetic energy instantly vaporizes and superheats the target rock.
And tektites actually get their name from the Greek word tektos, meaning molten.
Yes, so we aren't just talking about melting rock, we are talking about flashing it into a liquid state so fast and hot that the resulting glass has virtually zero water content.
That is the smoking gun right there that
Yeah.
separates a tektite from typical volcanic glass like obsidian, right?
Exactly. The extreme heat essentially boils away any trace of water.
Wow.
Then the molten material is ejected high into the upper atmosphere.
Or even low Earth orbit, I read.
Yes, before falling back down into what geologists call strewn fields,
Strewn fields, right.
which are these sprawling geographic zones where the cooling glass droplets eventually land.
It takes unimaginable energy to alter matter like that. And speaking of finding the right energy and tools to alter your workflow, let's quickly thank today's sponsor.
Oh yeah, Embersilk.
Right. This deep dive is sponsored by Embersilk. Need help with AI training, automation, integration, or software development?
They are fantastic for that.
Uncovering where agents could make the most impact for your business or personal life. Check out embersilk.com for AI needs.
It really is about utilizing the right forces to shape outcomes.
Definitely.
And the forces shaping tektites give them highly specific aerodynamic forms. As those molten blobs re-enter the lower atmosphere, they spin.
And freeze into these crazy shapes, right? Like teardrops and dumbbells and flanged buttons.
Exactly.
And here's where it gets really interesting because the local wildlife has actually adapted to this cosmic debris.
Oh, the emus.
Yes, our sources mention that in the Australian strewn field, emus swallow these ancient, perfectly shaped glasses to use as gizzard stones.
That is incredible.
They literally use impact glass to grind up their food.
It is amazing. But this raises an important question, though, about how we interpret those perfectly aerodynamic shapes.
Right, because they confuse people for a long time.
What's fascinating here is for decades, those exact flanged teardrop structures completely misled the scientific community regarding their origin.
Yeah, I read that even brilliant NASA scientists in the mid-20th century were convinced tektites came from the moon.
They were. They thought those aerodynamic shapes proved the glass had fallen through Earth's atmosphere from space.
Which was a fair hypothesis at the time.
Absolutely. But if they were so sure they were lunar volcanic ejecta, what was the specific chemistry that finally proved they were terrestrial?
Well, the true smoking gun was isotopic analysis, right?
Exactly. The logic they used versus the actual data.
When researchers closely examined the chemical signatures, specifically the isotopic ratios of elements like rubidium and strontium, they didn't match Apollo lunar samples at all.
Not even close. Instead, they perfectly aligned with the crustal sedimentary rocks found right here on Earth.
So what does this all mean?
It proves that science is a continuously self-correcting process. We adapt our models when the chemical evidence points us back home.
It is a wonderful example of science evolving.
If we connect this to the bigger picture, tektites represent a profound synthesis of Earth and the wider cosmos.
I love that way of looking at it.
They are physical memories of a dramatic moment when an extraterrestrial object reshaped our planetary crust into something entirely new and resilient.
They really are. If you enjoyed this podcast, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.
And before you go, I want to leave you with one incredibly optimistic thought.
Oh, I love these.
We mentioned strewn fields earlier, and scientists have confidently linked 3 of the 4 major ones to known impact craters.
Okay.
However, The source crater for the vast Australasian field, which dates back about 780,000 years, remains completely undiscovered.
Seriously, still undiscovered.
Yes. Somewhere out there, our planet still holds wondrous, massive geological mysteries, just waiting for curious minds like yours to uncover them.